The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, wherever you are in the country. It's Mark from SolidCAM. We'll be beginning our SolidCAM Live today. 30 minutes of free training. With me today is Kevin Rankel. Hey, Kevin.
Hey, guys. How's it going?
So, if you guys have any questions, you can always give them to me, but we will be continuing our next in the series of starting from scratch on a part. And if you're looking at my screen right now, you're seeing basically I'm recalculating that toolpath from yesterday. I know this is where we left off, so this is kind of a nice little continuation from yesterday, but what I'm actually doing is I'm recalculating the use of the second tool with its own working area, because I noticed, if you look on screen right now, the toolpath we're looking at is using tool 57. That's my 1-inch diameter tool, and you can see that in this case right here, it's avoiding the fixture. But the second tool that we're using actually has enough room between the fixture and the part to actually go and remove a little bit of material there. And obviously I don't want it to do that because that's where we're actually holding the part. So you'll notice once this is done calculating that you actually have the ability to add a separate working area for that one tool. So in your multi-tool window over here, I can actually click on, in this case, tool 38, which is my 1/2-inch tool, and I can tell it in the geometry section to use a working area. And I can't really show it now because we're in the middle of calculating it, but if I toggle between my tools here, I get my own set of parameters here. So in this case, with this tool, if I wanted to add its own working area, which is what I'm doing here, I have that ability. So the working area applied when I have tool 38 selected here only applies to tool 38. If I go back and toggle to tool 57, that tool doesn't have to use that working area. It doesn't see any of the parameters I'm plugging in there, which is very useful for the multi-tool functionality, because you can imagine that let's say I switch to a completely different tool to do some of this, the semi-finishing, the semi-roughing, and it needs to have a extended length, and I don't want to have the same technology wizard settings, or I might be using some sort of bull end mill for certain applications throughout this selection of multi-tools. So the fact that you can get a separate set of parameters for each tool literally makes this 2 tool paths in one window, because you get that individual functionality. And if I uncheck this box, we'll see basically that's what I've done. So originally I had the tool going in between here, and I wanted to correct that by adding this working area right here. So basically what I've done with the working area, and we talked a little bit about working areas yesterday as well. This green chain that I have selected here represents the outside of the target. And what I've told it to do is keep the tool completely inside of that area, only up until the center. So the center of the tool can actually wander outside of there as far as the edge of the target. So if you take a look at the graphic in the bottom left corner, that's basically right to the center of the tool. That tool can wander as far out as the center. So that allows the tool to eliminate any kind of cusps on the corner there. It allows the tool to machine everything inside of that working area, but limits it so it doesn't actually go too far out. And that's exactly what I'm looking for in the case of the space between the part and the fixture. And if I toggle to tool 57, you'll see that it doesn't have a working area applied. So that's that functionality right there.
And what we could also do, if we didn't want it to get that material out of there, we could just set up our Z height just being a little bit higher up. And that would probably help out with that too, wouldn't it, Mark?
It would, definitely. But if I wanted to retain the same functionality of being able to go down to the bottom of the stock here, then I would leave that. But basically, exactly like Kevin said, there really is no need in my case, the way I set up this part, for tool 38 to go past that level right there. So I probably could have just said, go as far as maybe the bottom of the pocket, and then that's it. So that functionality also exists. But that also highlights the fact that you can set individual levels per tool as well. And that goes back to that example of maybe you have an extended length tool or a stubby tool. You could do your 3D iMachining with a standard length tool. And then if you have deeper areas where the same diameter tool is required, but you need something a little longer, then you can set it up so that you add it in a multi-tool. It actually has the exact same diameter, but because it's an extended length tool, it can go deeper into the part because the 3D recognition is recognizing that there's more material that the previous tool cannot reach. It can do that. And we actually have examples of that in other videos on the YouTube channel where you're doing basically just a very deep pocket. And because of the holder collision protection and because of the just the auto collision detection in general, you're basically just going as far into the deep pocket as possible with the tool that you've selected. Then when you do your multi-tool, you choose a different tool completely, and it has more reach and it could go deeper into the pocket. So there's a lot of functionality with this toolpath, and this is why at least I suggest this being your first toolpath to use, because there's a lot of stuff in here that you might not be checking, you might not see how deep the pocket is, or the fact that the holder that you currently have selected probably can't reach there, but that's the tool that's in the machine, or that's the tool you're intending to use. You want it to just automatically figure out as best as possible how to use that tool. So 3D iMachining is a perfect toolpath to start with because it'll recognize all of that up front and figure a lot of that out for you. But we were talking yesterday about the different packages. So if you had just 3D iMachining, if you had the 3D package, you could use 3D iMachining. In this case, if I only had 2D, I could do something very similar. You still get the multi-tool functionality in 2D iMachining, and you get the same ability to set up separate working areas. So really the only difference between 2D iMachining and 3D is the fact that the 3D can do this taper, and it can do a lot of recognition of some other stuff that 3D and 2D have differences in. But mainly, it's that one 3D feature. Now, if you don't have the Pro package, 2.5D Pro or 3D Pro, and you just have the standard packages, then this could be done with a series of pockets. Using the Smart Face feature, you can actually just click on the bottom faces of each of these pockets and then get it to automatically recognize geometry for you and get a very similar functionality, except here you would have to add the step down, the step over, and the fees and speeds, whereas iMachining will provide that for you for optimization of the toolpath. So that's just roughing it out. This guy should now be completely roughed out. We can check that by checking this box here and then bringing this down here. This will calculate the status of the stock at this point. So we'll get to see where we are in terms of machining the part. Before we move on to finishing the part, any questions on 2D iMachining, 3D iMachining, the probing we did yesterday, any of that?
It's a quiet group.
Yeah. No, they're not just quiet. They know what they're doing, so they have no questions. Okay, so you can see that we're getting to the final updated stock calculation. That percentage right there is basically just the percentage of calculation, obviously. But once that's done, we will actually see the status of the part where my little follower is right here. So the status of the part after doing that one toolpath there. And if you don't see that, all you got to do is just right click on it and then click on include operation. So it includes this current operation. It actually will reflect the status of the stock at that point, or if I uncheck that, it'll be basically the status of the stock before I get to that toolpath. So if we zoom in here a little bit, you can see that our fixture collision protection came into play there because it came as close to the stock as possible. So it actually machined all that material there. And we can see some scalloping on this face here. So this thing is pretty much all roughed out. It's got 20 thou on all faces. Now we can go into finishing. So with a large part like this, again, if you just have the 2.5D package, you can do pocket and profile. Again, you choose your individual geometries, fees and speeds for your finishing tool and all that. If you have the 3D package, you've got a lot of different options to work with. For a part like this, I'm thinking, what do you think, Kevin? Maybe HSM?
Yeah, that's probably how I would tackle the next one.
So HSM, we've talked about a little bit before, but HSM is another solid recognition toolpath. So the reason I would use it here is to avoid the individual selection of all those pockets. I basically would just open up HSM and I'll say from this top left corner, which one of these would best fit what we're doing here. Now, I know we did our favorite toolpaths, and I think Kevin had one here that he liked. Which one was it? It was the combination, or was it the horizontal? Okay. So the horizontal, just to piggyback on previous videos, the horizontal will let us do the bottom of all those pockets, anything that's completely flat. And this kind of goes back to what we were talking about in one of the previous classes this week where, or at least I mentioned, there's no need to face this thing because now that I've roughed it out, really the only thing I need to clear up on here is just this kind of ribbed, kind of spider web kind of shape. By doing horizontal, I could do that if I wanted to. But that also might be a waste of the use of this tool. I'm going to use a tool that has enough of a diameter that I can finish these pockets pretty quick. So I'll still save this top surface when I'm using a smaller diameter tool.
Well, and even kind of look what Mark is talking about doing the top. We don't have any stock up there. Is kind of how we did it, or how Mark set up the stock.
Oh yeah, that's true. Yeah,
so I guess there is no reason to even finish that up there. But since Mark only left that 20 thou on the wall as well as the floor, this horizontal, we can do it all in one cut. Unless we're cutting into some very hard material, then we would have to do step downs. But with the horizontal, it's going to clean up all our flat floors and our flat walls for us, which is a real nice and easy way to do it.
It'll clean up the walls only because of the fact that if the tool is doing the floor and it gets close enough to the wall, then that's why it'll do the wall. It's not specifically designed to do the walls. It's just because this tool that we're about to use probably has enough reach and enough, I mean, like Kevin said, if the material, it yields itself to that, we can just do the wall as we're doing the floor. Otherwise, you go down here to combine constant Z. So the constant Z portion of this combination could do the walls. And then you can combine that with horizontal. So you use the same tool to do the walls and the floor. And then you can tell it if you want to do the floors first and then the walls, or the walls first and then the floor. So you have the ability to do that as well. But for this part,
we could actually do prismatic machining too, the one right above it, which is set up for the flat floors and flat walls too. So you guys, I guess what Mark and I are getting at here is you have a whole slew of options. It's just how do you want to machine your part, not how does the software want to machine your part.
Exactly. I always break it down like this. This is a box of tools, and you choose whichever one you're more familiar with, more comfortable with. So if you know how to manipulate the parameters of the combined constant Z with horizontal, then do that. If you're more familiar with and more comfortable with the prismatic part, then use that. So that brings us to the question. So if those do almost something very similar, the combined constant Z with horizontal and then the prismatic, what's actually the main difference between the two? What would be the deciding factor between those two? And I'm asking only because I know Kevin has done this in a KevCam previously. So what is the main difference?
The main difference between prismatic and like horizontal, well, you kind of mentioned it already, but the main difference is with horizontal, we're taking it all in one cut. So we're not really worried about stepping down because we only left that 20 thou on there. But maybe we're trying to achieve a really nice finish. That's where we'd want to go to the prismatic because we can select our step down as well as our select over or our step over. So that would be to get maybe a real tight tolerance on a hole or a real nice finish. Or if you do have more than that 20 thou material on there or harder material, that's where I would go with the prismatic because we can control the step down as well as the step over with that prismatic.
Okay, so in general, HSM, like I mentioned, is a solid or more specifically target-based toolpath. So in terms of geometry, it's very similar to the 3D iMachining. I just have to tell it I'm looking to machine the target, or at least looking to finish the target. And for whatever reason, it thinks I want to do it in Mac 2, so I'm just going to switch this to Mac 1. Tool, since we're looking to do the flat bottom, I'm going to choose a flat tool. And maybe just even for simplicity, once again, let's choose what we already have on screen. Let's do, let's stick with that 1/2 inch. We'll go with the 1/2 inch.
And if I could toss out the idea here, since we do have those radiuses on the bottom, what if we went with a bull nose?
You're right, we do have radiuses on the bottom. So let's do our search to our master tool list. Just to review this once again. So like Kevin said, so we're looking to do this all in one go, the floors and the walls. So definitely I want a tool that has a corner radius on it, and I'm going to go back and grab that tool. So in the master tool list for aluminum, I'll do a filter. So click on that triangle. This time I'll clear all and look for a bull nose. So I'm looking for a flat bottom, but also something that has a corner rad. So bull nose. There it is. And there's only so many here that satisfy our requirement. So I don't actually have to do a filter this time. I'll just click on the word diameter and put them in order. So if I was looking for a 1/2 inch, there's my 1/2 inch. Now, I don't necessarily know for sure if that 45 thou rad is going to match our part. So what I'll do is I'll still just add it. And you can see that we have the ability to actually, let me just check this. This has a, what is that, 1/16? I don't know. Metric versus inch. You're talking about a Canadian here. But that rad is not this rad. So what you can do is you can import the tool from your global libraries, and then once you bring it in here, modify it. So let's say we did have a tool that had that same radius. So let's put this in as 0.62 or whatever that is. So now that is a 1/2 inch tool with a proper rad to do that corner. This being a non-iMachining toolpath, I want to double check my data here to make sure my feeds and speeds make sense. Since I took this from the SolidCAM master tool list for aluminum, I'm going to get mad at Kevin if these feeds and speeds are not right. Because this is aluminum part, and I took it from his aluminum list. But basically, those are guides. You always want to double check your data to make sure the feeds and speeds are correct. But go ahead, Kevin.
As a speak out from this, I got told I had to dial down on my feeds and speeds because I was going too fast for these libraries. So these are going to be much slower.
Okay, so constraint boundaries. Now, unlike the iMachining, you don't necessarily have to add a working area in iMachining to get it to work. You can just add it and it'll do the entire part. For HSM and HSR, you actually want to add something. It won't actually let me calculate unless I put something in here. So if I set it to created manually, it'll just grab the outside of our target. Now it comes out almost like a rectangular because it's really just to flush on all edges, but essentially that's probably what I'm looking for anyway. Although in this case, if the tool can fit in this little area here, it might try and finish the outside. And I'm not actually looking for it to do that. So what we'll do is we'll go to created manually, user defined. When I click on new, it works exactly the same as pocketing and profiling. It's the same chain selection window. I could do the same thing where I did this. I just grab that, do a constant Z, and then I'll limit the travel of the tool to only inside of there by maybe centered. So we'll make sure that the tool can actually go as far out as the radius, make sure that we leave behind nothing in those corners there, maybe just up to that point. But basically, this is still limiting the travel of the tool. So I'm telling it to machine, or in this case, finish everything it finds within that chain, but staying within the chain as much as the center of the tool. That being said, if there's something about the tool where I want it to kind of just go out a little bit more, but I want to still control it by the center, we have this offset value. So I can tell it to wander a little further out of the part by just giving it a different chain, just basically offsetting the chain. So if I say maybe offset it by an additional 30 thou, or actually let's offset it by the radius, the corner radius. So it actually goes just that little bit out. That's not going to let it go too far out where it's going to go and do things I don't want it to do, but it gives it enough room that it can wander outside if I need it to. Let's go to passes. This is mainly a finishing toolpath. So it defaults to wall offset and floor offset of 0. But if I were using this toolpath for whatever reason and maybe do some semi-finishing, I have the ability to plug in some numbers here. We're doing horizontal, so all I get is control over the radial offset. I do get control over a minimum and a maximum if I want to, but I'm just going to leave it as the minimum here. And since this is a 1/2 inch, I'll set it to a minimum offset of 250. And smoothing, you can see here, if I just check and uncheck, that basically tells you what it does. It just kind of smooths out all the movements of the tool so that it comes out as arcs. Detects core areas, rather than always plunging into a cavity, if it can do a side entry like it could do here, I'll just check the box that says detect core areas. And then refine corners, instead of doing 90-degree turns, we can always get it to do a little bit of a radius there. You see in the bottom left corner. Oftentimes, if you're not sure what an option does, you can see it in the bottom left corner. It gives you a graphic, or you can always click on our little question mark here and then click on the words, and it brings up the help menu, which we've reviewed once before in our videos. Top right corner are the limits of this toolpath. So again, as a 3D recognition toolpath, we're giving it the limits of the travel, not necessarily how deep into the part we want to go, but actually how much of the part we want it to recognize. So the question we had before of should we do the top face, in our case, we don't actually have any material on the top face to do, but if I did want it to recognize the top face and machine it, I could actually set the Z top to just above this top face and it would actually recognize the material there. So I could actually say, going from 0 and then in the delta box, add some material in the plus direction and it would recognize the top face. But in our case, I want it to just skip that face there. So I'm just going to leave this as 0. And then for our Z bottom, since we're doing horizontal, there is no point in going deeper than the bottom of the pocket. So I'll just make that associative there as well. So that limits the travel of the tool that direction. Smoothing is where you can control how it refines the arcs when you check that box. Axial offset, I never actually played with this myself. Kevin, what does this actually do to this guy?
If you want to do offset the geometry.
Oh, okay. So you can actually give it the offsets there. And then edit passes. This actually is a pretty important window where you can actually get it to trim air cuts if it recognizes from the solid, and you can actually do a little bit of gouge checking as well to different. I think it's different surfaces if you click on this.
Yeah, different surfaces or fixtures or any kind of geometry that is there, you can do a gouge check against.
Yep.
Now, with HSM, there is no gouge check like HSS, so it does the gouge checking internally. But
yes.
If that geometry or the target isn't part of that, it will gouge through it. So that's where that gouge checking comes in handy.
Yes, yes. So automatically it'll gouge check against whatever's here, but this section gives the ability to include something else.
Yep.
Okay. Link section. So link is where you can control the movements of the tool. In this case, I wanted to do climb milling with this tool. You can link by level. So if you click on this, you'll see in the bottom left corner that instead of just doing this boss, then moving on to that one, I can actually get it to do this one, then that one, back and forth, so that it actually does it by level. This is kind of more of, I'm guessing, maybe more for like a thin wall kind of thing.
By Z level, so it contains it to a specific area. So what it will do is keep everything contained within a certain area and then move on to the next area instead of bouncing around.
Oh, okay, because that kind of looks like it would bounce around there. One,
yeah.
2, 3, 4.
So if you turn it off, it's going to contain it all to one level and then move over to the next level. It's not going to do the bouncing back and forth.
Oh, okay. Ramping. So in this case, because all that material has already been removed, I'm going to do a plunge ramping. I don't necessarily need to do helix, but you have the option here of profile and helix ramping. And then the rest of this, a lot of times people aren't really touching this either, but this helps you to further refine the movements of the tool in this one toolpath. Because it's an automatic toolpath, a lot of this is going to be pre-calculated, and then you can come in here and just kind of tweak it a little bit. Very similar to what you would find in 3D iMachining. 3D iMachining has a lot of defaults as well that a lot of people use, but there's always the parameters in there to further dial it in to get some better movements and better accuracy as well in certain instances.
Yeah, and one thing to remember with, all these different operations that Mark's showing you guys here right now, usually by default, these are set up as best as we can for the part. Now, you don't have to go through and change all these. You can just kind of go in there and modify it if you're looking to really fine tune that tool path and get everything looking the exact way that you would like it.
Absolutely. So doing the horizontal machining calculation here, and I didn't give it any wall offsets, so it will also finish the wall very much like what Kevin was mentioning. And you'll see that I guess I probably should reduce the Z top a little bit because it's actually doing the top face as well. So we'll take that off.
Yeah, and that's where the benefit of those deltas comes in handy for you guys. Is you can set the Z top as the top of the part, but if Mark puts like a minus, something real small in there, it will completely avoid that top surface.
There you go. So now you can see that it avoided the top surface, and the toolpath is just doing the horizontal areas. So all my flat bottoms have been done by the part. Now, the time it took to calculate that, I think we could do it with Turbo, right? Turbo has horizontal?
Yep. I think, nope, it does not.
No, it doesn't. It was not included there. Okay.
We could do that as linear as well.
It probably wouldn't be as clean though. I'd probably do more of a step over.
Yeah.
Yeah.
But like I said,
the difference between that is, let's just go back to this window here. So HSM has all the options that we talked about, constant Z, prismatic, and all that. The Turbo was introduced, was it 2019 or 2020, Kevin?
Oh, well, Turbo has, I want to say 2018, and then Turbo 3D HSR was introduced in 2020 this year.
Yeah, yeah.
And
The
with
turbo
those,
versions of those are just faster calculating versions of those. There's a little bit of more functionality, more related to specific surfaces in terms of gouging, but overall, the idea of turbo is to make it calculate much faster than its previous version.
well,
So
and
there's more options here, but this one calculates faster. But
and
go ahead.
two, with the turbo is kind of a hybrid toolpath. So it is a hybrid between HSM as well as HSS. So if you when you open up that operation, you will see some of the stuff in there is pulling from the HSS module, and some of it is pulling from the HSM module. So
Yep. Specifically what you mentioned earlier about the gouge checking. You actually have the ability to do gouge checking in the exact same manner as you did with HSS. In the geometry section, no, it's actually not geometry. Where is it, or am I thinking about Turbo HSR, where you can actually choose the individual surfaces for those offsets? I think it's probably HSR. Yes, okay, so this is what I was talking about. I thought this was in HSM, but HSR is another toolpath you could use if you don't have 3D iMachining, and Turbo HSR, like Kevin said, was introduced very recently. This, in my opinion, is a competitor now to 3D iMachining, because there's a lot of cool stuff in here that if you watch the KevCam, what was it, maybe like a week or two ago on this, this is a really cool toolpath because you can actually do individual offsets on faces and that sort of thing. So we've had some customers that in demos and training, they've asked, well, what if there's separate surfaces that have to have more or less material than other surfaces? This toolpath will allow you to do that. You'll be able to rough out the entire part, but leaving, let's say, 20 thou on certain surfaces, and then another set of surfaces, maybe just 10 thou. So it actually will keep track of that for you and do different roughing on different surfaces.
So I guess I like, as kind of a little bit of a wrap up of kind of what we've just kind of gone through just today, we basically did 3D iMachining, got it all roughed out, and then now we came back with the 3D HSM and pretty much finished everything in there, our flat floors, our flat walls. And now basically all we have really left is our drilled holes as well as our taper that Mark is showing right there. So really neat. I mean, we got a pretty decent part here with a lot of cavities, a lot of holes, all that stuff. And we were basically able to do this all, I would say 90% of it all within 2 operations or 3 operations since we're using multi-tool.
Yep.
But we'll still continue tomorrow finishing out this part for you guys.
Oh yeah, for sure. Well, from start to finish. Okay, so let's see. How can someone control tight tolerances? Tight tolerances with HSM is the question.
Well, I mean, when it comes to tight tolerances, you know, on something like that, you know, what you can do is, you know, up on those walls, if we do have a tight tolerance in there, and, you know, Edwin's bringing up a great point of tool compensation. For that particular one, what I would do in that case is come back with either, you know, a 2D iMachining finishing or a profile operation in there. All those do support tool comp, or we could also do a pocket recognition too, which will support tool comp also. But you know, if we're talking really tight tolerances, I would definitely come back with a profile operation, maybe run a couple passes around. I mean, and I'm talking tight tolerances, anything smaller than, you know, half thou. So if we're getting into the 5/10 tolerance, plus or minus 5/10, then I would definitely come back, do like an eye finish, because in there we do have the ability to do multiple or spring passes, what it's considered. So it's actually doing multiple passes in there to get that really tight tolerance area. So.
Yep. And to answer Edwin's other question, iMachining does have compensation.
Yep.
When you're doing eye finish.
Yep.
Okay, so Scott's question. So if you use the bull end mill in multi-tool 3D iMachining, would it have done the floors and the corner radius? Basically, it considers it as the same tool. It would just do the corners, recognizing that it's not going to gouge it. But yeah, it would do the corner radius just because of the shape of the tool.
Yep. Yeah, any geometry that is there, it would recognize it. So, you know, if we wanted to, if this was, if we step back a little bit, if we had a pretty wide open tolerance on this part, and this part was a internal component where it was not going to be like a visual appearance kind of part, what Mark could actually do on this one is do 3D iMachining and put a 0 wall offset and a 0 floor offset, and it would machine it up to size. And when I say tight tolerance, anything larger than plus or minus, probably plus or minus 8 thou or larger, we could just go right up to size, putting a 0 for the wall offset and for the floor offset.
Yeah.
And that's, I mean, the biggest thing at least I want to get you guys used to on this is we are working on a fully 2D part here, but we are utilizing 3D functionality to make Mark's job easier as he's programming this. We're not having to go through and click on multiple surfaces, go in there and, you know, it's the ease of the programming. And this, you know, for the majority of this, Mark did not have to go and open up the machinist handbook. He didn't have to go look up at the feeds and speeds. It's all being supplied there for you. And we do have, Edwin asks, what's the reason for HSM not having a decomp or diameter comp? The main reason why is usually with HSM, you're using a ball end mill. And ball end mills are, there's no point in using a comp on there. Some of the HSM operations do have compensation in there. I think it's under the passes page. Somewhere it's a tool or 3D tool compensation is what it's called. And like I said, it's some of them have it, some of them don't. And it always gets me a little tripped up on where it is or which one has it. But some operations do support it, and I think it's more of a calculation than anything, Edwin. Yeah, and Edwin is saying it would eliminate a secondary pocket or profile operation if HSM already had that to use. And like I said, you know, this part can be machined in plenty of different ways. Instead of using HSM, we could have tackled it with a pocket recognition, and where you would have that full compensation there.
Yeah. So it goes back to what we were talking about. There are many tool paths in the software. You just choose the best one for what you're trying to do. So all those different scenarios that Kevin's been bringing up would require different tool paths, because in some you want compensation, in some you're just going to set the wall offset to 0 and just get it done anyway. Some don't even need roughing and finishing. If this was not even a non-metal, we were talking to a customer earlier this week that was doing some sort of fiberboard kind of material, and he doesn't even require a roughing versus finishing. He just goes right down to 0, and it just does all his wall offsets at 0. So a lot of the times you look at these toolpath lists as just toolboxes. Basically, they just have a bunch of toolpaths in there. You choose the best one for the application. Okay. So we're near the end. I'm just going to run this in the background for some visual. But if you have any other questions, Kevin's going to put my email in the chat section. Send me your questions. Send me your topics you'd like covered. We'll continue this tomorrow as well. We'll probably finish this tomorrow because, like Kevin said, there's not much else to do on here. But if you'd like to see another part done, let us know. We can start fresh on another part that shows maybe other kind of functionality. If you guys do turning, we can do some turning as well. We haven't done too many a lot of turning. On Memorial Day, I did some turning, but if you guys want to see more of that, let me know. Kevin, you were going to say something?
Yeah, I mean, let's throw that out to everybody that's in the night class, in the live class right now. Would you guys want to see getting into turning and mill turn, or you want to keep focusing on the milling side of things? You guys tell us, because like you know, Mark stated at the beginning of the class, these classes are just for you guys. I mean, both Mark and I like teaching you guys, but we don't want to be teaching you something that you don't use on ever. So
Yeah.
you guys let us know if you want to start, you know, moving our way over to turning, or maybe want to focus more on 3D stuff. You just let us know. Okay. So it looks like we kind of got a mixture.
It's a mix, yeah. So what we'll do is we'll continue with this one to the end. There is still side 2 on this thing to do, so we'll do as much as we can on this one, and then if questions come up, we'll cover those questions as they come. But what we can do is we can do a start to finish on a turn part as well. Maybe we'll just redo the one that we did on Memorial Day, but we'll have to call it a day today because it has been time, and Kevin's tired. He wants to go to bed. So what we'll do. So emails in the chat section. Send me your questions. Send me your parts. If you don't mind looking at a part on YouTube, we can do that part from start to finish. You can see how we do strategy on that one. Also, the idea that there is a finder's fee for SolidCAM. I bring it up because it is very beneficial to us, but it's super beneficial to you guys because it's a little bit extra money, and all you got to do is just put us in contact with someone you know in the industry that can handle. That would use the software to their benefit. Maybe they need a little bit of an improvement, especially nowadays. Anything we could do to help people get back into business. Obviously, the software is a huge thing for some people. So let us know. You're entitled to a $100 gift card if they get into a demo. 20% of the sale if it goes to sale. So absolutely, put us in contact. Or put them in contact with us, and there's a finder's fee associated with that. We will continue this tomorrow for sure, and until the end of June, every day at 2 p.m. Eastern time. Until tomorrow, stay safe, keep your family safe, stay busy, and we'll talk to you tomorrow.
All right, thanks everyone.